Okay, so hi everyone. Thank you for joining. And this is the first talk. We're in the essentials track, and I'm going to cover getting started with ScyllaDB. And let me present the slides. Okay, so I see people are still joining. Let's take another minute or so and get started. We're in the essentials track. My name is Guy, and I'm head of training at ScyllaDB. Today, I will start with an intro to NoSQL in general and to ScyllaDB specifically for those of you that are new to ScyllaDB or haven't heard about it. And after that, I will jump right in and show you a quick hands-on lab. So just a lab that shows you how easy it is to get up and running with ScyllaDB, performing some basic queries. After that, I'll cover some basic concepts and the architecture of ScyllaDB. And then I'll talk about the read and the write path, probably just the write path. And if we have enough time, I'll show another lab, hands-on lab about high availability. Okay, so as I mentioned before, ScyllaDB University, this is how it looks like. It's a great resource for learning ScyllaDB. Most of the topics are covered in ScyllaDB University, and you can just create a free user and take different lessons at your own pace. It has labs, videos, slides, and so on. So you're welcome to check that out. And then there's the documentation. A few seconds to respond. Can you see the poll, Michael?
Yep, I can see it.
On the polls tab.
So guys, just make sure you go to the session tab on the right-hand side and then click on polls. And then you can select one of the different options and submit your response.
Okay, cool. So I see most of the people heard about it from a colleague or a friend, and then also some people from social media. So that's good to know. And let me continue. Okay, so a quick introduction. I'll talk about NoSQL in general. So what we're seeing here is the CAP theorem. And the CAP theorem states that in usually in NoSQL, but in distributed databases, there are three attributes that we would like to strive for. And they are availability, consistency, and partition tolerance. However, the CAP theorem states that we can only, there's a trade-off, and we can only achieve 2 out of the 3 attributes. Okay, so let's go over them quickly. Availability means that we'll always be able to serve requests in our database and answer queries. Consistency means that, well, there are different ways to define consistency, but one definition is that for every read, we're going to get an answer that is the latest write for that data. And before, when I talked about availability, being able to serve requests doesn't mean necessarily that those requests are going to be consistent. Okay, and the third one is partition tolerance, and that means that even if there is a network failure or for any other reason, the nodes cannot communicate with each other, then the system would still continue to work. And in the slide, you can see different logos of different databases. So for example, MySQL here, as well as many other databases, give a preference for availability and consistency over partition tolerance. Other databases like MongoDB give a preference for consistency over availability. And here we can see ScyllaDB together with Apache Cassandra and Amazon DynamoDB. And these databases give a preference for availability over consistency. Now, that does not mean that they're not consistent. They are consistent, and the consistency is tunable as well. And I'll talk more about that in just a few slides. Okay, so another way to think about NoSQL databases is by their data model. and we had some questions about that earlier in the lounge before the event. So here, going from the most complex, from the least complex to the most complex, we have key value databases where there is simply a key and the value. It's very simple. Examples are RocksDB, Aerospike, and Redis. Next, in terms of complexity, document store databases like MongoDB, where data is stored as a form of a document, for example, XML or JSON or some other structured document. Next, after that, we have wide column store databases, and here we have ScyllaDB, Apache Cassandra, and Amazon DynamoDB, as well as many others. These are just examples. And with wide column stores, you can think of the data as stored in tables with rows and columns. And finally, we have graph databases, for example, Janus Graph and Neo4j, where data is modeled according to edges and vertices. And by the way, Janus Graph can work with ScyllaDB as the underlying data storage. Okay, so that brings me to ScyllaDB specifically, and some of the attributes of ScyllaDB, I mentioned it in the welcome talk, are high availability, meaning that the system can serve requests even if some of the nodes are down or unavailable. It works with, or it can work with multiple data centers, and data is replicated, meaning there are multiple copies of each piece of data, which creates redundancy, and that goes together with high availability. Second attribute is high scalability. So the system works in a cluster of multiple nodes, and it's quite easy to add nodes to scale the system up. So say you're running an e-commerce application and you know that Black Friday is coming, you can simply add more nodes without any downtime. You could do it as the system is up and running. And then you will scale up your system. And maybe after Black Friday, you can remove those nodes. Third is performance. So the system provides low and consistent latencies and a very high throughput. Low maintenance. The system has auto-tuning capabilities, and it's easy to maintain. And finally, drop-in replacement for Cassandra and DynamoDB. So if you're running an application that's using Cassandra or DynamoDB, you can simply replace the underlying database with ScyllaDB and get lots of benefits. If you're coming from an Apache Cassandra background, then you probably had some experience trying to configure and tune garbage collection, and you would also see spikes in performance. With ScyllaDB, you don't have to worry about that. It's written in C++ and not in Java. So you don't have to worry about garbage collection. And if you're coming from Amazon DynamoDB, one of the main benefits, in my opinion, is that by using ScyllaDB, you can avoid vendor lock-in. So ScyllaDB runs on different clouds. You can run it on-prem, and it's open source. So you avoid the vendor lock-in that you have with Amazon DynamoDB. Some of the design decisions. So Scylla works in a shard per core architecture as opposed to the thread model. In the thread model, when we have a job, we have a thread pool, and a thread is selected to perform that job. You can see that's what we see here on the left-hand side, whereas in the shard per core architecture, we have designated resources, and that would be CPU, networking, RAM, and so on. And those resources are allocated per shard, and that shard is responsible for a part of the data in our database. Okay, and by using the shard per core architecture, we avoid context switching, deadlocks, and that translates to improved performance. And what we see in this slide is on the left-hand side in the thread pool model, we have a bunch of puppies and some bowls with food, but some puppies are eating from the same bowl, some bowls are empty, some food gets spilled and it's quite a mess, which translates to bad performance. Whereas in the shard per core architecture, each puppy has their own designated bowl with their own food, and I don't know, they seem happier to me in this architecture. So they're all eating from their own bowl and they're all happy. In terms of ecosystem compatibility, I mentioned compatibility with Apache Cassandra, which is quite a popular database. So if you have a driver or a third-party software that works with Apache Cassandra, it will work with ScyllaDB as well. And in addition to that, we have ScyllaDB optimized drivers, which utilize things like the shard per core architecture to improve the performance even more. So I won't go into all of these, but you can find the examples in the documentation and on ScyllaDB University. Okay, benchmarks. I don't really want to get into this. You can find the data and the different benchmarks on our website, but let's just look at one example. One of our customers switched from Cassandra to ScyllaDB, and they changed from 40 Cassandra nodes to 4 ScyllaDB nodes. The result was that it was 2.5 less expensive, and they got times 11 better latencies. So not only did they pay less, they also got much better performance. And of course, when you run 4 nodes as opposed to 40 nodes, the maintenance is also easier. So that's just an example, but depending on your use case, you can have a look at our website. Okay, so ScyllaDB comes in 3 different flavors. I guess I didn't mention it, but it's open source software. It's community-based. You can view the code on GitHub. I put the link here. You can view the code. You can make changes, maybe send a patch, add your own features. And if that's your thing, if you have the technical capabilities, you can use the free open source software. That's one option. The second option is ScyllaDB Enterprise, and that's our production-ready version. It's based on the open source version. However, the enterprise version has a few extra features. And very importantly, in my opinion, is the 24/7 mission critical support that you get with ScyllaDB Enterprise. So we have support engineers in different locations around the world, and they're ready to help you. So if you're running an application that's critical for your company in production, then I welcome you to check out ScyllaDB Enterprise. And finally, we have ScyllaDB Cloud, which is our database as a service offering. By using ScyllaDB Cloud, we take care of managing the database for you. You don't have to worry about it. And we see more and more users are choosing this option, more popular. You can get a free trial on ScyllaDB Cloud, check it out yourself. You can run the labs that you're going to see here, or on ScyllaDB University, on ScyllaDB. Great. So after the intro, and before I explain the basic concepts and the architecture, I want to actually show you a quick hands-on lab. I'm going to be mentioning different concepts that I didn't really explain, but bear with me. I just want to show you how easy it is to get. Okay, great. So you can see the lab right here. And what I did right before I started talking is I clicked on this command, and what this does, it runs a Docker instance of the ScyllaDB software on this environment. It's called the Killer Coda environment, and I'll send you a link to that after the event. So with this environment, you can run examples directly from your browser. So no prerequisites or anything special to install, it just works. And what I did was I clicked on this command. I did it before the talk to save some time, as it downloaded some files, and it simply started a single instance of ScyllaDB. And then I clicked on the second command, and it's called node tool status. And what this does is it shows me the status of my cluster. In this case, I have a single node in my cluster and it's up and running, and I can see the called it my whoops, I forgot something. Didn't work. I need to connect to my instance. I can create my key space, and this time it's also going to work. And now, using this key space that I just created, I'm going to define a table. I'm going to call it users, and this table has just a few columns: user ID, first name, last name, and the primary key is defined as the user ID. And I'm going to talk about these concepts in just a bit. And once I created my table, I can simply insert 2 rows into my table. So I insert Rick Sanchez and Rust Cole. And now if I select the data from this table, I perform a read query, and I can see that the data was indeed written to the table and that I can read it. Okay, so that's a very simple getting started lab, just to show you how easy it is to get up and running with ScyllaDB. And now let me go back and explain some of the concepts that we just saw, and also the architecture, so how ScyllaDB works under the hood. And I'll also say that everything that I'm going to be talking about is Apache Cassandra as well as ScyllaDB. So at this level, great. So the first concept is a node. I mentioned that a few times, but I never really said what a node is. So a node is a computer server running the ScyllaDB software. It consists of shards, and in ScyllaDB, each node contains a portion of the database content. Okay, so in a typical cluster, we have multiple nodes, and each node is responsible for some of the data. In ScyllaDB, all the nodes are created equal, and that's very important. It goes together with high availability. So we don't have this concept of follower leader nodes or master slave or however other you want to call it. All the nodes are created equal. And that means that even if some of the nodes become unavailable, there's a failure, for whatever reason they don't work, the system can still serve requests because all the nodes are equal. Next concept is the cluster, also called the node ring. So this is a collection of nodes. In production, we typically have at least 3 nodes in a cluster, and this can go all the way to hundreds of nodes working in a single cluster. And the number of nodes depends on many different attributes, such as the hardware you're using, the amount of data, the performance you require, and your specific application. So that's out of the scope of this talk. And you can look at sizing. I'm not sure, but it might be covered in the advanced track in the last talk. But if not, there's information about it on ScyllaDB University. And in the cluster, in the node ring, as I mentioned, all nodes are created equal, and they communicate between themselves in a peer-to-peer fashion, okay? And that again means that there's no single point of failure, goes together with high availability. That brings me to partition key. So this is what happens under the hood in Scylla. In this example, we have a 3-node cluster. There are 3 nodes, X, Y, and Z. And what happens when the user wants to write some data, say this row? So this row has an ID column, and that's defined as the partition key. Now, according to the partition key, which by the way can be more than one column, what the system does, what ScyllaDB does, is it performs a consistent hash function on the data of the partition key. And according to the hash, the system knows which nodes are responsible for that specific row. Okay, so each node has an assigned token range that it's responsible for. And according to the hash function that's performed on the partition key, ScyllaDB knows which node is responsible for which piece of data. And right after my talk, Tzach is going to talk more about partition key, clustering key, and other data modeling concepts. So that's in the essentials track right after my talk. If you're interested, then stick around for that. So I mentioned data is replicated across the cluster. There are multiple copies of each piece of data. And an important concept here is replication factor, also abbreviated as RF. And that is the number of nodes where data are replicated. So if, for example, I have a cluster with 5 nodes and I define the replication factor as 3, then that simply means that each piece of data that I have is going to be replicated 3 times. So a copy of it is going to be placed in 3 different nodes, okay? And the replication factor is defined by the user, of course, according to your application needs. And once you define the replication factor, the actual replication of the data is done automatically by the system. So you don't have to worry about that. And that setting, the replication factor is set per key space. So in your application, again, depending on your specific use case, you might have more than one key space. And it's easy to understand that if you have a higher replication factor, you're going to have more redundancy, and your data is going to be, you could say, safer. So that goes together with high availability. But the trade-off, of course, is that you're going to need more hardware and more disk storage because you're going to keep more copies of your data. Consistency level, also abbreviated as CL, and that is the number of nodes that must acknowledge a read or a write request. And some examples of CL, the consistency level, are 1 or quorum or all, and there are many other examples. And you can define the consistency level per operation, and that's also called tunable consistency. And what that means is it means that each operation can have a different consistency level, right? So let's say that you're, for example, you have an IoT application and you're writing, say, the temperature of the room every second. That's your query. So maybe the consistency level doesn't have to be so high because it doesn't really matter if you miss 1 second of recording the temperature. On the other hand, if you're doing a complicated read of the data and doing some important calculation with it, then maybe you want to set the consistency level to be higher. And maybe this is a bit complicated. I'll explain a bit more when I provide an example. Okay, so data centers, I mentioned ScyllaDB is designed to work with multiple data centers, and it's topology aware, so it's aware of the different data centers, and also it's aware of racks within each data center. So in this example, we have 2 data centers, one in the US and the other in Asia. And that can make sense for multiple reasons. One is possibly for regulation reasons. In some geographical locations, the data needs to be stored only within that country or within that region. So by using data centers, we can do that. Another is for performance reasons. So it would make more sense in this example, say, to serve a request for from a client that's coming from the US data center, not from the Asia data center, just because of the time it takes physically to transfer the data from, say, Asia to the US. And another reason is, of course, again, high availability. So even if one data center, say there's a fire or an earthquake or for whatever other reason, one data center becomes unavailable, then we can still serve requests from the other data center. And by the way, the synchronization between the two data centers can be done asynchronously. So I can, for example, write data to the US data center, complete the query, and the two data centers would sync without me having to wait for that. Maybe one more point about data centers is that just like nodes, data centers are also created equal. We don't have a leader, follower, data center, anything of that sort. Okay, just to make sure you're still with me, let's do another poll question. So if you click on the polls tab next to the chat, the next one is, have you used ScyllaDB before?
Guy, we're not seeing it yet, so maybe it can take just a minute or so. We're still seeing the old poll.
So the question is, what's your experience with ScyllaDB? It's below the first one. The first one is, how did you first hear about ScyllaDB? And then below it, there's another one, what's your experience with ScyllaDB? Can you see it now?
Yep. So you can just scroll down in the poll tab and you will see the question.
Exactly. And the options are, this is the first time I'm hearing about ScyllaDB. I heard about ScyllaDB, but I've never tried it before. I'm currently evaluating it, or I'm running it in production. So if you can take a second and just answer that question. Okay, so I see different answers here, but most of the people heard about ScyllaDB but didn't try it before, so you're in the right session, in the right track to learn more about it. I see that some people are evaluating it and others are already running it in production. So let me move forward. Thank you for your answers. And I talked about the replication factor and the consistency level, but I know those concepts are a bit, they're a bit complex. So I want to show you an example just to show you how it actually works, and hopefully that will make it more clear. So I'm going to show you a cluster level write, and this is what happens in ScyllaDB under the hood when we perform a write query, okay? So in this example, we have a cluster with 5 different nodes. These are the nodes V, Z, Y, X, and W. And the replication factor in this specific example was defined as 3. If you remember, the replication factor defines how many replicas or copies of each piece of data ScyllaDB is going to keep. And in this case, it was defined as 3 nodes. Okay, so we have a client. The client wants to write a piece of data. I just called it 1, but imagine this is a piece of data. And the client sends the request to one of the nodes. In this example, it chose node V. It did so very naively. There are optimizations for choosing a node that already is a replica node, but that's more advanced, out of scope for this talk. So it shows one of the nodes, say node V, and node V is now defined as the coordinator node for this specific operation, okay? So the client sends the request, please write the data 1 to node V. coordinator node V performs the consistent hash function on the partition key of the data, if you remember from before, and it sees which 3 nodes. We have a replication factor of 3, so which 3 nodes are responsible for this specific piece of data, and it sees that these 3 nodes are W, X, and Z, and it passes the request directly to them. Please write data 1 to those 3 nodes. Those 3 nodes, in this example, successfully write the data and add it to the existing data. And after they write the data, they send an acknowledgement back to the coordinator node saying the write was successful. Okay? In this specific example, the acknowledgement, the ACK from node X to node V didn't pass. Okay? So let's say there's a network failure and the ACK message failed for some reason. So node V only knows about 2 nodes that responded with an ACK. Now, what do you think would happen here? Would this write be successful, or would it be considered a failure? The consistency level is defined as quorum. You can quickly write in the chat window if you think it's successful. Okay, so I see some people are saying it's successful, and you're right. Because the consistency level is defined as quorum, then 2 out of the 3 nodes would be a quorum. And since 2 out of 3 nodes sent an ACK that was received by the coordinator node, node V would return success, an acknowledgement to the client saying the write was successful. Now, in this exact same example, if we had a consistency level of all or of 3 instead of quorum, then in the exact same example, the write would fail and node V would not return the acknowledgement to the client, and the client would have to either retry or try to do something else. I see a question about retry. That's quite complicated, and that's going to be covered in Piotr's talk, and that's the 3rd talk in the advanced topics track. Okay, in the next talk, in this track, the essentials track, Tzaf might touch on that, but Piotr is going to cover that. And if you still don't get an answer, please ask it in the expert panel because it's just more complicated.
Yeah, okay. Just a quick heads up, about 5 minutes, so we can take maybe just a couple of more questions afterwards.
Sure. So let me wrap it up. This is another example. Just instead of write, we have a read. So I'm going to skip that. And then I prepared another lab, but we're not going to have enough time to run it. And this lab also uses the Killer Coda platform, and I'm going to send you the link to it. You can run it after this event. And in this lab, you're going to create a 3-node cluster, which is more realistic because in production, we don't run single node clusters. And you're going to create a 3-node cluster. And in that cluster, you're going to be performing read and writes with different consistency levels. And we're also going to be simulating a situation where some nodes are down, they're unavailable. So does the write succeed? Does it fail? Of course, it depends on the numbers and on the consistency level, but you can just play around with that and try it out yourself after this lab. After this talk, you can run the lab yourself. With that, let me wrap it up. So we have a few more minutes for questions. I mentioned ScyllaDB University, university.scylladb.com. I'm going to publish the slides and the labs on 2 courses and send you the link for those. Check out our community forum. If you have any questions, if you want to see what other people are doing with ScyllaDB, you can just join and interact with the community there. If you want to download Scylla open source, there's the link, and you can also find it on GitHub if you want to actually view the source yourself. And as I mentioned, if you have a use case you're not sure about, get in touch with us, and by all means, we're happy to help. We have a lot of experience, different migrations, different use cases. Get in touch and let us know, and we're happy to help. Okay, so we have time for maybe a few questions.
So I see there's a question from Raghu about can we use Scylla as a cache alternative?
I'm not sure what you mean by cache alternative. I guess I would need more information for that. So yeah, that would also be a good question for the expert panel. We would probably need more information.
And then we've got Jignesh, I hope I spelled your name right. A use case is best suited for ScyllaDB.
Use cases best suited for ScyllaDB. So I don't think there's a specific industry. We have examples running running use cases from different industries, IoT, ad tech, financials, many different industries. And I believe we also have a segment on our website with different industries. In terms of the sweet spot for when to use Scylla, I would say that if you require high availability and you have lots of data, so big data, then ScyllaDB is a good candidate. You need low latencies and a high throughput. I would consider ScyllaDB, but I don't know if there's a specific industry that is the main one that's adopting ScyllaDB.
Yeah, I will also post a link for resources on ScyllaDB, which has a lot of different use case scenarios. So feel free to check that out. I just posted the link.
I see a question by Brian about data encryption. So the question is data encrypted at rest in transit. So there is an option to encrypt data both in transit and at rest. For one of them, I think it's an enterprise feature. I don't remember which, but we can check that out. But it's possible to encrypt data both at rest and in transit. Okay, let me also remind everyone that we have the expert panel after the third talk. So that would be at 11 a.m., I believe. We're going to have an expert panel with myself, with the founders of the company, with our CTO, and some of the speakers. So if you have questions that are not answered, keep them for the expert panel. The next two sessions right after this one. So in this track, in the essentials track, we're going to have Tzach, and he's going to be covering core concepts of ScyllaDB, and that would be things like how to choose a partition key, clustering key, using drivers, collections. That's an interesting talk. And meanwhile, in the advanced tracks, starting at the same time after this talk, there's going to be a talk covering ScyllaDB and Kubernetes. So there's the open source ScyllaDB Kubernetes operator, and Tomasz is going to be talking about how to use it. He's going to give an overview and also show you a hands-on demo. So if you're interested in Kubernetes and ScyllaDB, that's the session for you. And with that, please head back to the stage. Thank you, Michael, and I'll see you later in the next talks.